Welcome back, welcome back. We had a phone call, so this got interrupted. We were just starting to talk about Henry Becquerel and the discovery of radioactivity, which he did on accident. Okay, that caught up everybody who's having to watch online. Like, I'd say your names. I know who's home, but I won't since it's going on YouTube. All right, so anyway, he had some glow-in-the-dark rocks. And what he wanted to see, y'all know glow-in-the-dark, right? I have, where did I put it? I always try to show this off. Oh, here it is. My medal I got for my road race I ran this summer. Maybe I'll wear it. You know, they give them to you and you just never know what to do with them. Maybe I should wear my glow-in-the-dark medal for running my road race. Yay. I came in 4th for my age division. Yes. Almost made it to the podium, but no. Okay, glow in the dark. So if I took this and held it up to the light and let it charge and then turned off the light, then the part that's painted light you could read, right? Everybody's played with glow in the dark. Okay, so he had rocks that were glow in the dark and he was trying to figure them out, playing with them. And he wanted to know, if you have something glow in the dark, is it a big enough source of light that you could expose film with it? Could you take a picture of glow in the dark? Everybody understand his original experiment? Okay, well, he got through with his experiment. It was time for the weekend. He took his rocks, his glow-in-the-dark rocks, and he took his film, unopened, unexposed film, threw it in a drawer together for the weekend. Should the film have been able to make a picture just being thrown in a drawer with glow-in-the-dark rocks over the weekend? No. So it gets to be Monday. He takes out his film, opens it up to continue his experiments, and the film has been exposed like it had been held up to the sun at noon, he said, like the sun at noon. So he went, whoa, something here is going on bigger than glow in the dark. Turns out the rocks he had some uranium in them. What do we know about uranium? Very toxic and radioactive, right? Well, part of the rays being given off by the rocks were not just glow in the dark. The rocks were giving off X-rays. So he discovered radioactivity. He had glow in the dark rocks and photographic plates. They happen to have uranium in them. He discovered X-rays. He called them X-rays. He could have called them Becquerel rays after himself. But instead he called them X-rays because he didn't know what they were. They were mysterious, so they were X. Like the X in algebra is mysterious. You don't know what it stands for till you do the problem, right? It was an unknown X. Okay, so he was friends with Marie Curie. Back to our lady scientist, yay! Have to cheer for her. I used to have a video. It wasn't even a video. It was a film strip. It was this like thing of film, and you put in a projector, and then you played an album, an LP, a vinyl, and it'd have a picture on the screen, and then it'd go beep, and you'd flip it, and it'd be another one about her. And I just loved it. It was so funny. And it was like old technology back when I taught public school before. And the kids just thought it was fun to see what it was like, what a film strip was like, and it was about her. And I would check out the Media Center, and I went one day to check out the Media Center video on the film strip of Marie Curie, and they said, oh, we threw that away. It was old. I was like, no, it was so fun. So sadly, you don't get to watch the film strip of Marie Curie and get to hear it go beep and flip it forward. Get to do that old school technology. Okay, so she was friend with Henry Becquerel, and what she did is she started figuring it out. He discovered it and shared all of his findings with her and her husband, and she understood it. Okay, so they figured out radioactivity. They figured out that this uranium had too many neutrons and was unstable and was giving off radiation. So back then, where you presented scientific information was in Paris, in front of all the Academy of the Sciences, and her husband, Pierre, was heading off to go tell everybody about it and go speak, and he was killed by a taxi cab. He got hit while he was walking across the road. A taxi cab hit him and killed him. Now, this is the weird thing. This was back before World War I. It wasn't a car. It was a horse-drawn taxi cab. They still had horses back then. We don't think about that, but they did. So he was trampled to death by a horse. Isn't that horrible? not watching where it was going. So bad for the horse and him, mostly him. So then she was the only person in the world who understood this. They had a rule that women were not allowed to speak in front at this place. Women were second-class citizens. They were not allowed to go to school sometimes, and certainly not allowed to speak before the most prestigious men in the world. But she was the only person in the world who understood it. So guess what? They changed the rule, and they let her speak, and she came and explained it to them. I just love that story. I'm like, yeah. All right. So her husband died. He got hit by a taxi cab, and she was the first woman to speak to the scientific community. Yay, Marie. And she continued working with radioactive elements and kept refining them, and she discovered two elements, radium and polonium. She did not name them after herself. She named radium after radiation that it gives off, and polonium after her country, Poland. So later they went back and honored her with curium and named one after her because she didn't name it after herself. Okay? So then, fast forward. Marie, she had two daughters, three daughters actually, I think. But anyway, one became a famous movie star. That's kind of fun. And the other one became Irene Curie-Joly, who discovered the neutron. Women in science ran deep in that family, or beauty in movies, right? All right, so then there's another woman. Okay, so now fast forward to World War II. There was a woman named Lisa. Some people call her Lisa. Some people call her Lice. I don't know. I don't speak German. She was German. So I'm going to call her Lisa because that's how I heard it first. Lisa Meitner. And she was in Germany right before World War II. And German scientists, remember, did some amazing scientific stuff. They discovered all kinds of stuff. Remember, Hitler thought he could win World War II by scientific advancement. You know, go watch the Marvel movies, Hail Hydra and all that. It's based on reality, that they were really trying to use supernatural and natural scientific means to get ahead in the war. They tried to use supernatural stuff too. Okay, so Lisa was working as a chemist in Germany right before World War II, and things start getting bad for the Jews. She's working with two other lab partners who are German men, but she, even though, from what I understand, her religion was Christianity, I think she was Presbyterian even, her ethnicity was Jewish. I've had kids be confused by that. Jewish religion and Jewish ethnicity are two different things. You can have Jewish religion without Jewish ethnicity, like there was a famous singer, Sammy Davis Jr., who was African American, who believed the Jewish religion. And you can be Jewish ethnicity in different religions. Y'all understand this now? Okay. So she was Jewish ethnicity, not Jewish religion, and she was a scientist working with radiation at this time. So, didn't matter. Did Hitler care about your religion? No, he only cared about your ethnicity. So things started getting bad for Jews, and they started thinking she was in danger. So her two lab partners, the German guys, pooled their money, sold their jewelry, did what they could, and they snuck her out of the country, got her out to safe Switzerland. So she's living in Switzerland, but can't work in Germany at her lab anymore. But the guys continue the experiments, and they are sending her the results to help for her to look at the data and see if she can figure it out. They had done an experiment, they didn't understand what had happened. And they had the ray gun, you know, everybody's got the ray gun, you got the gun, you want to shoot something with it. And they were taking the ray gun and they were shooting radioactive rocks with it. Well, what happened is they didn't get they thought that if they shot the rock, they'd get more radiation out of it. You know, sounds fun, right? But instead, they got two completely different elements that they weren't expecting to find at all. So they said, we have no idea what happened. They sent her the the data. It was Christmas time. She was celebrating Christmas, and her nephew had come, I think, from the United States. I'm not sure about that. He had come to do Christmas with her in Switzerland, and he was a scientist too. And they look at the data, and she understood it. She realized that they had split the atom. So this was a huge advancement in understanding science, that atoms can be split. Remember Dalton? He said it was indivisible. Not with liberty and justice for all, but indivisible. This is when we figured out, nope, you can split atoms. At the same time, Einstein had figured out E equals mc squared. What is E equals mc squared relating? Do y'all understand it? You've heard it, right? It's that matter and energy can be converted. That if you go down the hall and see Miss Raymond's room, she said, you matter. Unless E equals mc squared, then U energy. Energy and matter can be converted from one to another. And so she realized at the same time that they had done, split this atom, and that some of the matter had gotten converted to energy. Later on, they will use this idea to make the atomic bomb. They ask Einstein, since he's the one who figured out E equals mc squared, to help him make the bomb in something called the Manhattan Project. We'll probably talk more about this when we go back to radiation in Unit 3. But he said no, because he too was Jewish. And he said he would not help, that if a bomb was made, eventually that people would try to use it on Jews, that historically the Jews have been persecuted, and he was not going to do anything to help in persecution of Jews. It's almost like he was psychic, because what's going on right now is Iran is trying to get a bomb, and what did they say they want to do it with it? Bomb the Jews. They want to bomb Israel out of existence. So isn't this interesting how all this fits together? Religion, science, politics. This is a very interesting part of science history, because it was right there at World War II when all of this is going on. Okay, so her lab partners, Lisa Meitner was Otto Hahn and Fritz Strassmann. They were working on radioactive elements. It was World War II. She figured out they had split the atom. See, they're shooting the alpha particles. The symbol for alpha is this little fish. And they hit the atom and split it. This is called nuclear fission. Fission. It sounds like a fish. Fission. So I want everybody to imagine a fish. Imagine your hand as a knife and split it. I want you to remember that splitting an atom is fission. You got it? There's another one called fusion, and that's what's going on in the sun. Hydrogen is being fused into helium. It's the other kind of nuclear reaction. But this is our first one, splitting the atom. The opposition is putting elements together, nuclear fusion, and that's what's going on in the sun. So now imagine fuse. You fuse things to put them together. Imagine you're fusing the sun together. Can you imagine that? Keep those words straight. They're hard because they must start with F. All right, so the next person is Enrico Fermei. Isn't that a great name? I just love it, Enrico. He was the first, so they figured out about splitting the atom that causes, it could cause a bomb. And he was the first person to be able to control a nuclear reaction. Okay, or a nuclear chain reaction. They thought when they made the bomb that they might blow up the whole world, because one atom splits another one, that splits another one, and so on and so on. And they said, where's it ever going to end? So they were afraid that when they did it, either it was going to be so hot it would catch the oxygen in the air on fire and catch the world on fire and burn it all up, or that they would blow up the whole world in a nuclear explosion because of chain reaction. And they made it anyway. They made the bombs anyway. That's how afraid of Hitler they were. They were building the bomb to stop Hitler and to stop Japan too. But when they started it, it was Hitler, and they made it anyway in the Manhattan Project. Okay, so the atom. So the atom is made out of protons, neutrons, and electrons. What charge do protons have? Positive, and you can remember that because positive and protons both start with the letter P. Okay? What charge do neutrons have? Zero. They have no charge. And so don't let that fool you. Because protons start with P and are positive, students will get it wrong. They'll say neutrons negative. Neutrons neutral. Neutrons neutral. It still matches, but it's neutral. And then what are electrons? Negative. And they're very small and they spin. Now there are actually, that's a negative. There are actually more subatomic particles like quarks, mesons, gluons. And from what I understand, you will learn about those in physics next year. When I taught physics, we taught those. I think they're still part of the standards. Okay, now why do we have dominoes knocking each other down? That's our chain reaction. Just like how one domino knocks down another one atom splitting sends out particles that hit into other atoms and split them. We're going to do a little lab with dominoes. We will not actually use nuclear uranium or anything, nuclear bombs, for safety. All right, let's go on. We can get through all these notes today. Okay, so I told you we'd go back to Bohr and his model. So let's learn how to do this real quick. We got time. Okay, so Bohr's model, how you do it is you look on a periodic table and you look and see how many, what its number is. What's its whole number? It's its protons. So over here, can y'all see what the number is for hydrogen? It's 1. I know we need to pull those off. So hydrogen's number is 1. Helium is 2. Lithium is 3. Beryllium is 4. Boron is 5. Carbon is 6. So step 1, look at the periodic table, find the whole number, and that's its number of protons. Good so far? Okay, next what you do is you draw the nucleus and you put as many protons in there as it has. So this one has 1 proton. I drew it as a circle with a plus. And then if it's neutral, if hydrogen is neutral and it has 1 proton, how many electrons must it have? 1. So we draw an orbital and we put an electron in it. And that's the Bohr model of hydrogen. Yay! Okay, good so far? Okay, so helium. We're going to draw the nucleus. How many protons should I draw in it? 2. So let's see if I can do that. Y'all can probably do it better than me. I'm making them green dots, okay? How many electrons should it have? 2. So I'm going to draw my 2 electrons here. Now, look back at helium. If you look at helium, it has a decimal number that is 4 something. Do you see it? It's 4.002. Y'all probably can't see that far. Knowing that its mass comes from the protons, no, we don't even count the electrons, they're too small. Then its mass is 4. How many neutrons do you think it has? 2. Do you understand where I got that? 4 minus 2 is 2, so there are 2 neutrons. So I'm going to change my color. You can too. We'll make it purple. And I'm going to draw 2 purple neutrons. Ta-da! The Bohr model for helium. Okay, let's do lithium. Let's see if you can do it by yourself. Draw the nucleus. Now draw 2 orbitals. How many protons goes in the nucleus of lithium? 3. So draw 3 protons. I'm going to make them purple. Now, over here, if we look at the mass of lithium, it's 6.9. So we round it off to a whole number. What would 6.9 round up to? 7. What's 7 minus 3? 4. So we're going to put in, I'm going to make them a different color. I'll make them pink. I'm going to put in 4 neutrons. 1, 2, 3, 4. And now, how many electrons do I put? 3, because the same number as the protons, because it's neutral. So, now this is a little bit tricky. The first energy level can only have 2 electrons. So I'm going to draw 1, 2 electrons in the first level. The next one can take 8. So I'm going to put 1 in the next one. And that is the Bohr model for lithium. All right? Everybody's crying. Y'all seem to be handling this just fine. Okay, let's try beryllium. Now, I'm going to show you sometimes instead of drawing them all, people will put P dash N dash and just tell you how many. The symbol for proton is lowercase p. The symbol for neutron is lowercase n. And the symbol for electron is lowercase e. Okay, so beryllium, how many protons would it have? It's right here. It's got 4. So sometimes they'll just put 4. Its mass is 9. So how many neutrons does it have? 5. So we can put, okay, and now we can draw our electrons. 2 in the first level. Oh, how many electrons will it have? 4. 2 in the first level, 2 in the second level. Okay? You think you got it? Everybody try boron by yourself, and I'll do it up here, and I'm going to do it the shortcut way too, because now they're getting too big to draw all the circles in the nucleus. Boron's number is 5, and boron's mass is, we'll round it to 11. We'll say its mass is 11. Okay. Did you get it? How many protons?
5.
How many neutrons?
6.
How many electrons in the first level?
2.
How many electrons in the second level? 3. Got it? Okay, let's try carbon. It'll be our last one. So carbon's mass is 12. Its number is 6. So its mass is 12. So everybody try it. And then look up here. Okay, so how many protons?
6.
How many neutrons?
6.
How many electrons in the first level?
2.
How many in the second level? So somebody doing the report, I don't know if it was in this class, said carbon has 6 protons, 6 neutrons, and 6 electrons. It's 666. It's evil, and it's what we're made out of. Was that in this class? It was. There you go. I was like, I never thought about that before. Okay, so this is our thing. Okay, well, our next topic is called ions. Okay, if an atom gains or loses an electron, it gets a charge. If it loses an electron, okay, think about it. If it's got all of its electrons and all of its protons, it's neutral. 6 minus 6 is 0, right? But if it loses an electron, one comes off. Now I've got more protons than electrons. Does that make sense to you? So what charge will it have if it has more protons than electrons? Positive. So if an atom loses an electron, it becomes positive. And the name of a positive ion is a cation. If it gains an electron, what will it become? Negative. And it is an anion. Now, how do you remember this? Easy. Cats are wonderful, positive, sweet little creatures. So positive anions are cations. And some of you might disagree with that, but we'll all agree on the next part. Fire ants are negative, horrible, terrible creatures, very negative anions. Can we agree with that? In my old room, I used to have Miss Foster's room last year, and we had fire ants trying to build in the classroom. We had a little fire ant hill right by the door where they had destroyed the tile and was building a little hill. I had kids who were getting fire ant bites in chemistry class. So see, aren't you glad we're over here where it's fire ant free? Yes? All right. So let's talk about this last little bit. Is this the last bit of your notes? Let me see. I got it right here. Now we got areas of the periodic table, this, and isotopes. We got 2 minutes. We'll stop here, and we'll pick up with how to do this chart tomorrow. Like, share, subscribe. Science is great.